Hi, welcome to our introductory video tutorial for SESTralin. SESTralin is one of the main computation modules of the multi-lines and right-of-way software packages, and it can be used to compute scalar potentials, electric and magnetic fields, and electrostatic and electromagnetic induction effects. In this video, we'll see how to open SESTralin, and we'll see where input data, such as soil characteristics, is defined within the application, as well as how to specify transmission line components. And we'll learn how to execute computations of line parameters and sequence components, as well as how to view the computations. To open SESTralin, navigate to the SES software folder, shown here at the upper left corner of the desktop. Open the Tools subfolder, and then double-click on the icon for SESTralin to launch the application. SESTralin opens on this backstage, and on the left side you'll find your standard commands for creating a new file, opening an existing file, or saving a file that you're currently working on. For this video tutorial, we'll begin with an empty default project. So in a moment, we will simply click on the OK button without modifying any of the fields in the backstage. But before clicking that OK button, we'll quickly call attention to a few of the fields here. For example, the unit system, which can be set at metric or imperial, and here we'll keep it at the default setting of metric. The frequency setting, and we'll keep that at the default value of 60 Hz. And lastly, we have cross-section specification options, where you can select one of three specification modes: group mode, single mode, or circuit mode. So while SESTralin can be applied to any number of transmission or distribution lines with any type of conductors, whether they be above or below ground, single and circuit mode would only be used when all of the conductors of the system are above ground and uninsulated. Group mode would be the only suitable option for a system that includes insulated or underground cables. These modes won't be covered in detail in this video, but we can note that for the simple system we'll be defining, any of these three modes would work. To keep things simple, we'll stay with the default selection of group mode. Next, we'll click the OK button, which will bring up the soil model panel of SESTralin. We won't be making any modifications here, but we will briefly summarize the purpose of this panel and some of the settings that can be specified. As the name suggests, this panel is used to specify the soil characteristics that are applicable to your project. In the Type drop-down menu, we see that Uniform is the default selection, and with this selection active, we will have only two layers in the table below, one for air and another for soil. If you have soil data, then you might want to select Horizontal from the Type drop-down list, whereupon you'd have more than one soil layer to define. And here in the table, you would enter values for the resistivity, thickness, relative permeability, and relative permittivity of your soil layers, and you can add new layers to your soil profile if appropriate. But our goal here is to provide a summary overview of SESTralin's features, so we'll return the type setting back to the default value of uniform, and we won't modify the default resistivity value of 100 ohm meters. With our soil characteristics set, we move on to the cross-section tab, where you can specify the phases of your system, the locations of your system components, and your component types. For example, the type of material that your transmission line conductors are going to be made of. We will be specifying a three-phase transmission line, so we'll click the Add Phase button 3 times to add 3 rows to the specified cross-section phases table. Then we'll move down to the Define System Components table, where we can name our system components and specify their type and location. With respect to location, the y-axis is represented horizontally, and y-axes typically correspond to the horizontal distance of a system component from the center of a tower. The z-axis is represented vertically, so a positive z-value indicates the height of a system component, typically a transmission line conductor, above the surface of the Earth. Transmission line components are considered to intersect the yz plane at right angles. So we'll call our first system component Phase A, and then, in the Component Type column, we'll select Create New and then From Database to bring up SES Library. If you've already checked out our SES Library video tutorial, or if you're otherwise already familiar with this application, then you'll know that we can refine our searches for a particular item in the SES Library database by making one or more selections from the filter drop-down menus that are available here in the Category Filter window. We'll be choosing ACSR from the Conductor class filter. And then, from the table of ACSR conductors that come up after we click OK, we'll select the ACSR bald plate item and then the Import button at lower right to import that conductor item's data into our SESTralin project. We then specify the location of our first system component, so a horizontal distance of 13.6 meters from the center of the tower and 28.5 meters above the surface of the Earth. Finally, via the cell in the associated phase column, we assign this component to one of the phases that are listed in the Specified Cross-Section Phases table, here assigning phase number 1 to component number 1. We'll repeat this process for the remaining two phase components, specifying their locations and assigning each component to their respective phases. And then we'll add one more component to our system so that we can specify a neutral conductor. For this neutral conductor, we'll use an optical cable. So from the component type column, we'll launch SES Library, and from that database, we'll be selecting an optical cable for our neutral conductor. Lastly, in the associated phase column, rather than assigning our neutral conductor to a phase, we'll instead check this Eliminate Conductor checkbox. This effectively tells SESTralin that this neutral conductor is not energized, and it will be removed from the final parameter matrices, and its effects on the computational results will be embedded in the parameters of the phases. We also note that some advanced features are available in the Induction and Energization tabs. These features of SESTralin aren't covered in this video tutorial, but we'll just note quickly that some of these advanced features are only available in circuit mode. Returning to the backstage momentarily, we remind ourselves that we had selected the default group mode earlier in the video. We're ready to launch our computations, but first, by clicking the Sequence Components checkbox here on the Home ribbon, we're telling SESTralin that in addition to line parameters, it should also calculate sequence component values, also known as symmetrical components. So at last, we'll click on the Compute button here in the Home ribbon, and the computations of our line parameters and sequence components begins. When the computations are completed, we can see the computed line parameters here in the Computation Results tab, located in the panel of the same name. And the sequence components will be displayed in the Sequence Components tab. These computation results can also be viewed in a text file that will appear on screen upon clicking the View Report button. This comprehensive report specifies not only the calculated line parameters and sequence components, but also the data that was used to compute them, such as conductor and soil characteristics and the frequency of the system. We hope you enjoyed this video tutorial. Thank you for watching.